Hello, welcome everyone. Welcome to the second episode of Scaling with the First Principles series. Today we have Kailash Nadh, CTO of Zerodha, with us to discuss about scaling with common sense. Zerodha, as many of you already know, is India's largest stock brokerage. That means a big percentage of transactions of Indian stock exchange goes through Zerodha. That's a non-trivial scale. Would be interesting to know what kind of technology or processes goes into creating such a system. Let's welcome Kailash Nadh. Welcome, Kailash.
Thanks, Anand.
Yeah, so I'm really glad to have you on the series. So it's really quite curious to kind of know what kind of tech that goes behind Zerodha. So it's really nice to hear that like what you're able to achieve with such a small team is quite remarkable, and love to kind of know more about an inside story of that. So let's,
Sure.
for the benefit of everyone, can you start us let's telling about what is Zerodha?
Yep. Zerodha is a stockbroking firm. We started out as a discount stockbroker. Then, some 7 years ago, we started building technology for everyone to invest and trade in the markets. And over the last 7 years, we've transformed from just being a pricing-based discount stockbroker to an investment technology platform. So we offer investment and trading services to everyone. Anybody can sign up, download our apps or use our web apps, and just start investing and trading. So yeah, that's what we are. And today we are also the largest stockbroker in India in terms of the user base.
So, can you tell about like the kind of scale that you work with to get us a kind of idea of the scale that is like number of transactions that goes through or the amount of money that gets exchanged hands, etc.
Yeah, so we have, I think we are approaching a client base of 4 million users. But what matters to us is concurrency. In the markets, it's all about concurrency. And on peak days, we have more than 1 million people who log in and transact on our platforms. I think our highest day recently, on our biggest day, on a peak day, we clocked between 8 and 9 million transactions from end users. And on an average day, we do 6 to 7 million transactions. And when a key facet of trading in the markets is consuming market data, prices and ticks live via platforms. So when users log on to our trading platforms and track market data, we're streaming out ticks. Just to give you a scale, just to give you a rough idea of the scale at which we stream out market ticks. At any given second, we are streaming out probably 30 to 40 million packets ticks of prices that flash to hundreds of thousands of concurrent users.
That sounds like a pretty great scale. So, can you tell us like what's the tech stack like? I mean, what to get it like kind of set the context of what we're dealing with.
Yep. The first initial versions of the trading platform were built in Python because we wanted to build it quickly. But we've since migrated most of our user-facing systems to Go. We really like Go's concurrency primitives and the ease of writing Go. So, Kite, our trading platform, all our systems that handle heavy load and traffic, they're all written in Go. And we use Redis heavily as a database, in-memory database for low latency reads and writes. And for a non-critical passive storage, we have Postgres databases. There are many instances. Some are a few GBs in size, some are several terabytes in size. So Postgres, Redis, and Go. And for uh, non-critical or systems that don't really have to handle a lot of traffic, we still heavily use Python. And most of our backend number crunching systems, lots of those things, back office systems, are still in Python. Yeah. Hi, Anand, you're on
Sorry,
mute.
sorry. So, how do you host this? Do you kind of manage your own servers, or do you go with the cloud, or how does that work?
We self-host all of these systems. We use AWS for hosting these applications. We also have presence in physical data centers. Uh, you have to have those in this industry, terminating physical lease lines, etc. It's the norm in the stockbroking industry. But the applications that I just described, our databases, etc., are hosted on AWS, and uh, all these instances we self-host them. We manage our own Redis instances on bare uh, uh, bare EC2 instances. We don't really have managed database services or services at all. And most of these big critical applications are on just raw instances that we self-manage, and many smaller applications for many smaller applications, we recently started using Kubernetes and Docker, just for the sake of uh, just for the ease of deployment, and also to standardize the deployment process, not necessarily for scale. Yeah.
Got it. I think you also use ERP Next heavily. You built a lot of your stuff
Oh
on
yes,
Frappe, right?
absolutely. Yep, yep, yep. So a stockbroking firm, and for that matter, any financial firm will have a ridiculously large number of back-end processes. Accounts, ledgers, transactions, all sorts of complex financial, legal, and regulatory things that you have to do, and you'll have lots of different departments, different people with different roles and permissions who need to generate reports, who need to run tons of processes. So the bulk of our back office systems, the crux, in fact, the system is called Crux. We actually call it Crux because it's the crux of the business, is built on top of Frappe/ERP Next.
I think that gives us a context about the kind of technology we're dealing with. Okay, so now I want to ask you kind of a broad general question, like, how do you, what's your approach to building software, right? In the context of scale. So I think it's a quite generic question, but I think what I feel is like you have a slightly different perspective than many other people in the industry. So I would like to kind of hear about that.
Uh, I, I personally, I think I have a very hacker tinkerer sort of perspective. No matter what you're building, you start out with the smallest unit, the simplest unit. It doesn't matter what you're building, and it doesn't matter at what scale it has to operate. You focus on the problem and pick the right tools to build it in. It could be Python, it could be Go, it could be Java, it could be anything. You don't start out by saying, I am going to only use Java or Node.js or whatever. So, right tool for the right job is definitely a big it's a big principle. And starting small with small units is another thing. You can't foresee infrastructural or scaling requirements on day one of any business, especially a complex financial business. And scale you can't even quantify, because it could be the number of users, could be the number of transactions, could be a few users and massive amounts of transactions generated by those users. So you can't really quantify and foresee those things. So you don't start out by saying, I'm going to deploy X number of servers using Y technology, and create this sort of infrastructure on day one. So you start out really small. It could just be one server instance with one process running something, and you build it up from there. And once you have that sort of a framework running in a business environment, let's say a stockbroker, next time or the 10th or 12th time you start a project, you'll have a pretty decent idea of what stack you have to use, because 90% of it is probably similar to the rest of the projects that you've done. So you always start out small and simple.
That's interesting. So, I think one of the things that you always mentioned, like one of your blog posts, is like when keep it simple principle, the Unix philosophy, right? I mean, can you expand on that? Like, when how does it kind of how do you apply that to software? You keep also saying that use the boring technology, and so I think you always uh, seem to prefer to use proven technologies rather than going with the cutting edge. So, can you kind of expand on like what's your views on that, and also how it played a role in actually building your stack?
It's a trade-off. There's no. It's a little difficult to describe. Uh, Again, the principle that one must use to use when picking technologies. Like you said, boring is a synonym for battle tested. So when you pick a battle tested technology as opposed to something that was released just a week ago, the benefits are obvious. You get years worth of battle testedness to back up your choice. So that doesn't mean that you only use boring technologies. You also have to use bleeding edge technologies. That's where you take that bet. That's where you make that trade off. So we've used some bleeding edge technologies, and the bleeding edge technologies that have proven to be great choices. For example, we decided to ditch our mobile applications uh, and rewrite them in Flutter when Flutter was alpha or even pre-alpha. But that has worked out really well. But it doesn't mean that, we read Flutter's marketing page and decided to just pick Flutter. We in fact built a prototype over several weeks and built up confidence, and then decided to use that bleeding edge technology. So it's basically, again, it comes down to the right tool for the right job. Battle tested often wins 90% of the time, and 10% of the time you make an informed bet, a trade-off on an experimental or a bleeding edge piece of technology. But staying away from hype, definitely, for sure. You never read a technology's marketing page or whatever and just decide to use it. You have to build, experiment, prototype, whatever, and build objective confidence before picking it. And that's the rule that we apply.
Interesting. So there are a couple of questions. So I think I'll take the ones which are relevant to the discussion as of now, and then take the remaining ones later.
Yeah.
So one of the questions is, what are regulatory compliances, and how do you kind of manage that? Because I think it's ever changing industry, right? A lot of regulations, etc. So how do you kind of keep up with that, and what's your approach for that?
Oh, I think ever changing is putting it lightly. I think in the last 12 to 16 months, there have been so many massive regulatory changes. They, how the industry has worked for 10, 15 years has literally been rewritten with a deadline of, let's say, 2 weeks or 3 weeks. So there's no playbook for dealing with crazy regulatory changes. But if you have a good enough software architecture, even inside an entity as complex as a stockbroker, it gives you agility, and that also means regulatory agility. So like I said, we've kept everything really simple. Even complex units within the business with different departments, etc. The systems, they interact via, let's say, unified APIs, and uh, there are no hacky there's no hacky memory sharing or database sharing. For instance, there are no undocumented connections in API. So these units are all, I don't know, like calling them microservices, because they're not microservices. Some of them are really large services, but they have been architected in a way that they don't get in each other's way. Just common sense architecture. So when your software system architecture is malleable like that, with enough moving pieces that are all independent from each other, that gives you a lot of regulatory agility. And I would say that thanks to our simple software architecture, we've been able to cope with huge regulatory changes in really small amounts of time without actually having to go rewrite everything that we've done.
So one of the things that people talk about in software world is move fast and break things, and right. And so no, I want to kind of get your views on that. Okay,
Yeah.
I know that you won't agree, but I want to kind of hear the other side of your side of the story.
Yeah. Uh, I think move fast and break things that phrase has been abused so much, and that phrase has been used to justify so many random things, it's lost its meaning. I would say move, I don't know, it should be fast enough, and you shouldn't just outright fail. The failure, it's a trade-off again. Move fast enough so that you don't really fall flat on your face, because you can't really, 100% predict success or failure. So it's basically that. Although, like I said, we are very agile thanks to our systems, uh, and regulatory changes, etc., can completely change how the business works. But despite all of that, and despite the number of features, etc., that we release internally, we are extremely conservative. We may actually dwell on a feature for 2 months, 3 months, or 6 months. We may dwell on one tiny change uh, up until we are confident that that can be pushed out. So that's not exactly, move fast and fail, and you can't really do that in a critical environment like financial transactions. But again, ironically, because we are so cautious and conservative, and we've taken our time to design these systems in whatever ways that we've done them, that's in fact made us faster. We don't really have to move at breakneck speed to innovate. It happens at reasonably fast. It happens at a reasonably fast pace, despite us being extremely conservative. So that, I don't like that phrase. It's again a trade-off. Yeah,
No, so I mean, I think you're saying that you attribute that to your system architecture, how it kind of grown up.
for sure. Yeah, and the way our team has evolved, the culture of the team. Yeah.
Yeah. So, so can you kind of say more about? There's a question like, what do you say keeping architecture simple? What does that really mean? There is a question from Abhishek. Uh, right? Can you expand on that? So, what do you mean by keeping architecture simple?
Uh, it's very broad. There are many parts. There are many complicated parts of a stockbroking system. But just to give you maybe one example. So earlier I said that we have hundreds of thousands of concurrent users who are connected to our systems using WebSockets to receive live streaming market tips. Now, you might imagine it to be a system with hundreds, if not thousands, of uh, instances, compute nodes connecting and processing these requests and streaming out data. And that would be a really complex distributed architecture. But in fact, that's not what we've done. We just have, I think, a handful, a dozen instances. uh, I'm talking about EC2 instances on the AWS cloud that come up, and each instance has just one process, one binary. We call it the kite ticker, written in Go, that runs. And that one process with no dependencies just starts up, connects to uh, connects to a NATS feed. I mean, it's a pub subsystem, and starts receiving market ticks. Now, that one process can handle up to, let's say, 50,000 WebSocket connections coming from our end users and stream data to it. So it's literally one process on one EC2 instance with zero dependencies, zero distributed architecture, handling 50,000 concurrent users and streaming market data to them. Now, if you want to handle hundreds of thousands, you just add one more instance and run one more copy of that process. Or you can just have one big server with, let's say, 16 or 20 cores, EC2 instance, and just run two or three copies of this. So that even to handle massive concurrency and massive low latency tick streaming, and this is, I think, twice or thrice every second that we broadcast ticks to every single user. You just need literally one binary that runs on a bare metal EC2 instance, Linux instance. You don't need a complicated distributed mesh architecture, etc. It's just one process. And you can apply this to many of our services internally. They're just they're just independent single processes that come up, do their job.
Yeah, that's great. So, one part that you kind of mentioned right in your post is like most of these applications that you typically build, the bottleneck is always the database, right? And that's
Yeah.
so. I'm sure like you must be storing a lot of data in database and then using them and serving through your APIs.
Yeah.
So, so what's your approach to that? I mean, how do you so what are the practices that you follow when you kind of building applications with databases?
You start out with the problem at hand. So, console is the name of our back office platform. That's where you go and fetch reports, etc. And these reports can go back several years. And the database underlying console is it's sharded, and it has terabytes of data, billions and billions of financial records. And when you pull a report, it might take 1 second or 2 seconds or 3 seconds or even 4 seconds, but it's a fair trade-off. So the leeway that we have is that it's okay for a report on console to take 3 or 4 seconds to fetch. But on Kite, everything happens in about 50 milliseconds. Kite is a low latency trading platform, right? Everything there has to be instant. When a user places an order, it should the order request should go through instantly, which is, let's say, 50 milliseconds. It cannot uh, it cannot indefinitely wait for n seconds. So there are two kinds of these applications when we build applications. That's two kinds of the two categories: low latency and applications where latency is acceptable and tolerable. So in low latency applications, we make sure that we reduce the database IO, let's say Postgres database IO, as much as possible. When you place an order, when you click on a button to view your portfolio, etc., on a trading platforms, we are not really hitting our Postgres databases at all, because an RDBMS or any sort of distributed database, the latency will be unpredictable. It could be 2 seconds, could be 100 milliseconds. So you just avoid database as much as possible. That's where Redis shines. So Redis's latency, its performance is deterministic, very predictable. If it'll always give you a result in, let's say, I don't know, 1 millisecond. So on low latency applications in all our hot paths for storing stuff, we use Redis. For long-term storage, we might move that parallelly to Postgres. So that's what we do. Just avoid RDBMS, database IO, anything that is disk based, anything that commits or flushes to disk, completely on low latency hot paths. Anand, you're on mute
Yeah,
again.
sorry. I think there are a lot of questions from participants about how do you scale Postgres and what kind of scale, what's the data sizes that you operate. Can you kind of tell us more about the typical, what kind of, what's the largest database that you have, that you use? Okay. And have you tried any distributed databases? Yes, or if not, why not?
Uh, as I said earlier, we start out small. So we have, I think we recently, a few months ago, we sharded our largest Postgres database. I think it was several terabytes. I can't really remember, it was 2 or 4 or 5 or 6 terabytes, but definitely several terabytes. So, and there was a single Postgres node. Of course, it had a backup and all of that, but it was a single Postgres node with several billion rows, tens of billions of rows. I think 100 plus billion rows for some of our financial breakdown data. And that was a single node. Now, if a single Postgres node with terabytes of data and 100 billion records works just fine, why even look at a distributed database, right? So when we felt that maybe we were approaching the peak of what a single node could handle, we sharded it. Uh, and we already had logical partitions within it. So that's console, our back office. So it's very organic. We wouldn't really just go pick a distributed database because we're anticipating 100 billion rows 10 years from now. So you push every system to its max, and as you feel that you may be approaching its threshold, then you try to push it more, let's say sharding or whatever, making distributed. If you feel that it might not scale, that's when you look at a completely different solution. But with battle tested systems like Postgres that have been familiar to us over the last, I don't know, 20 years, you can very confidently push this forever. So yeah, hundreds of billions of rows, terabytes of data, even on single nodes, simple architecture. Yeah.
So wouldn't that cause a single point of failure? I think there are some questions again about how do you deal with availability when you
You
kind
have
of.
you have backups and replicas, of course.
So what would be tip? I mean, have you ever faced a situation where the database node went off and you had to kind of switch over to a replica?
Yeah, that can happen. It's very rare, it's completely unpredictable, but you have to have hot failovers. So we've had, for mysterious reasons, our main Redis nodes on, let's say, Kite, the trading platform, uh, become inaccessible. But in the next couple seconds, the Redis has a really simple thing called Redis Sentinel, which it's a little agent that runs between Redis nodes, and it'll detect failures and promote a replica as master. So those things kick in randomly. And the whole point of a hot failover is that you shouldn't even get to know. It should just happen. You shouldn't have to be involved. And then again, like I said, it's a trade-off. If you want hot replicas, instant failovers, there may be additional complexity. And for a trading platform, that is absolutely necessary. it should just switch over. But let's say the back office platform that people only really use at the end of the day to look up their reports, if it's not available for a minute when something is getting switched over, that is actually a fair trade-off. It doesn't affect anyone. If it doesn't affect, uh, I'm talking about a specific report, for example, like a passive report, something that is not critical in nature. It's okay for it to fail over several seconds or a minute. So you don't apply the same yardstick for making for failovers and replicas. You do it based on the problem at hand.
So do you see like are you reaching a threshold of what you can handle with Postgres yet?
Uh, I mean, 100 billion rows, it works just fine. But we sharded recently because we just felt that we've been running this for a long time. It was working just fine. We're like, maybe we should just shard, and we sharded. But of course, there were backups and replicas, but I'm only talking about sharding. Yeah.
So now you may have like 2 or 4 nodes. Uh,
I think two
to,
nodes.
2 nodes, okay. So you still see kind of long path before you can worry about figuring out if that's not enough, right?
Absolutely. I mean, this is still premature optimization. That's why battle tested technologies are beautiful, right? Everybody, the whole world has been using Postgres for 2 decades. We know how much it can be pushed. So you don't have to, on day one, think that I might get billions of rows. Let me just go get Cassandra or whatever. So these things work. Battle tested technologies work well.
Yeah. So there's there are a lot of questions pouring in. So I think I'll take questions as and when it's relevant to the current the topic. Okay. So
Yeah.
I think the questions are kind of pouring in. Okay. Everyone, please bear with me. I'm going to kind of go over all of them, but as and when it's relevant to the discussion. Okay.
Yeah.
So one thing that like a lot of people kind of asking is like you talked about you're self-hosting all of it, right? So
Yeah.
why do you self-host? I mean, isn't it better to kind of actually take a managed service? And I think the general wisdom in the startup world is basically you want to move fast. You want to spend your energy on actually building the product and use all the services around rather than actually building everything yourself. But you seem to be kind of doing completely the other way. So can you tell us like what's your idea behind that?
There are multiple reasons. There are business reasons. There are personal reasons from my perspective and us as a team, the kind of decisions we've taken. I think it's important for if you're running a service and your business depends on it. Imagine a stockbroker's database, right? I think it's important to have 100% control over every aspect of it. So in a managed scenario, you might really not get all the control that you need. So the kind of R&D that we've done on our Postgres instances, the kind of experiments that we've been able to do because we had access to the underlying file system, for example, is immense. We've done so there are these trade processes, etc., that happen at the end of the day when we get massive data dumps from stock exchanges. Those things 7 years ago, before we had our own tech stack, 7 years ago, when we had 1,000th the size of the data that we have today, those things would take 8 hours on external vendor-based systems. But over the years, we've R&D'd, pushed the databases to their limits, figured out lots of tricks, all because we have complete 100% control over the systems to optimize them to a point where what would take a decade ago, what would take 8 hours, today take 10 minutes. So I think it's important for a business to have 100% control over its stack and to completely own it. And there's also, personally, I'm very wary of vendor lock-in. I would, when it comes to my personal files or when it comes to the data that the business holds, any uh, any hint of vendor locking is I'm quite paranoid about it. And at today it wouldn't matter, the cost wouldn't matter, but at some point the cost also mattered to us quite a bit. Zerodha is bootstrapped. We've never raised funding. We're a really lean company, and one of the reasons why we were able to scale the way we've scaled, not just technology, everything around it, is also because our infra costs have been really low. So, like I said, today it's not a factor, but 5 6 years ago when we started pushing these apps out, every single dollar mattered. So there was the aspect of cost, there's the aspect of vendor lock-in, there's the aspect of having 100% control of your data within your stack, and 100% control of the infra that you manage so that you can push it to the next level. And uh, it's also about visibility. If you want to scale something like a Postgres to a single node, with a single node to whatever, you need to have uh, full visibility into its innards. And the managed service, it could be anything. I'm not just talking about Postgres. A managed service only gives you high level abstractions running on somebody else's infra. So it's about that confidence also. Uh, I'm personally more confident about these systems and the scale to the extent to which they can scale when I have full visibility. And I think all of us in the team, we operate like that. Our stack decisions are all based on these principles.
So that probably means that it's complete no to any SaaS service, right?
Largely, pretty much everything inside a tech stack, absolutely everything is, we self-host and manage.
Yeah. So then it comes on. I guess that also comes at a cost, right? You can't really. So everything you have to kind of invest. I'm sure like there is a long term benefit of doing that. Okay, but
Yeah.
in the short term, are you kind of ready? I mean, it's a consideration that you're ready to pay that price for that.
I think it's a misconception that if you self-host something, the cost, not just in terms of money, but in terms of expertise required, efficiency, energy, etc., could be massive. But that's clearly not the case, as we've proven in our case. So I think there is there's this uh, irrational fear of the cost that you have to pay to self-host. And I think to a large extent, a lot of SaaS slash cloud companies have perpetuated that. I don't think that's true. How can you expect to build a solid tech stack that can achieve massive scale at lean costs if you're not ready to understand a core system to your stack? For example, a Postgres database works. If you're not willing to spend time and energy learning Postgres or running your own whatever queue or whatever it is, how is it possible for you to just skip the fundamentals and go to market faster? Maybe it's probably 1 to a couple months. Now the thing is, ironically, if you do that and if you end up building everything on managed services, the cost in terms of money that you'll end up paying at some point when you actually hit whatever scale will be far greater than the few months you would have saved trying to learn these things. And more importantly, I think it's very important for developers who build these systems to understand everything about it. They should understand how the underlying systems work, all components of it work, how the database works, how latency affects these things. So you can't really be a good developer if you just offload bulk of your things into some, SaaS API.
So there are a lot of questions about like how do you manage Postgres? I mean, what kind of application do you use? What kind of file system do you use? Okay, there are many questions. I think can you kind of talk about like what's a Postgres setup like?
So I think Satya, if you're watching this, we have to write a blog post. So the console team, all our teams internally are 3 to 4 members max within the tech team. So the console team does all the R&D and management of the Postgres databases. And blog post is long due. So the bulk of the data that we store in our Postgres databases, they're not really real time. And that's actually a big boon. So as I said, the back office processes in this industry, it's all end of the day. When the market closes, we get massive file dumps from all exchanges, depositories, etc. Millions of rows, trades, positions, all sorts of things. And what we're supposed to do is take all of these files, collate, run them to many different trade processes, figure out accounting ledgers, etc., generate the results, and bulk load them into our databases, Postgres or whatever. Some of the Frappe instances that we use also have huge MySQL databases underneath it, by the way, because Frappe by default uses MySQL. So we have that too. So all of our Postgres tuning there there is organized around uh, time-stamped end of the day bulk loads of data. When I say time-stamped, I mean by date. Everything that happens in the stock markets is time-stamped uh, with a particular day, the trades that happened today, today's accounts, today's end of the day balance, today's positions, etc. So after lots and lots of trial and error, experimentation, etc., we figured that logically partitioning these massive bulk loads that we do at the end of the day, they work better when they're partitioned by months. So if you and we'd also, I think, experimented with partitioning by date, but then you end up with too many partitions. So we hit the sweet spot for our back office financial databases uh, with logical partitions that were done by month. So that helps immensely. That's the right trade-off between reads and writes. But you can already see that logically partitioning massive databases based on months will not be relevant to most use cases out there, most business use cases out there. So yeah, there's literally no formula. You just have to figure out the right trade-off for your business and your the kind of data that you're storing. But yeah, logical partitioning with Postgres is one of the biggest growth hacks we've done for our financial databases.
What's the file system? They use ext4 or ZFS or something fancy.
Just X4, ext4, yeah, nothing fancy.
Okay.
Yeah.
And what about the? I think there was some other question about what about replication? How do you do the replication?
So, for instance, for Kite, we have a we have a master and we have a hot replica, and it's just standard Postgres master to slave replica, sorry, replication. And we've experimented with PG Bouncer. In fact, we still use PG Bouncer is a little proxy sort of a system. So if you have multiple replicas, if you want to redirect some queries, read queries to replicas to offload the database, you can just use PG Bouncer. So our setup is again really simple: master slave replica with PG Bouncer in places for splitting loads.
So is it a synchronous or asynchronous replication?
Async replication.
Async replication. Okay.
Yeah. As I said, for us, our biggest databases are all end of the day. So we don't
Yeah.
really have to worry about real-time, low latency syncing. So that's a use case.
Got it. Okay. So now, so one of the things that I think underlying about like how you build software is also how you build the teams. I think that uh, is also very important part of uh, how your tech stuff kind of evolved in the shape it is, right? I mean, so can you tell us like how do you kind of what's your team like, team size, and how many people, and how do you hire, and how do you try to kind of find the right kind of people?
I think it reflects how we build our systems. Starting from a small unit is exactly how we've ended up building our team. When Zerodha technology was born uh, in 2013, uh, it was just me. So there was one tech person, and suddenly we had this thing called Zerodha technology. And in the initial days, there were no grand plans or goals. We didn't even have plans to build a trading platform. So I would just go sit with everyone in the company, the sales folks, support folks, risk management folks, etc. Sit with them on their terminals, understand their problems, and build little Python automations to fix them. So file downloads from the exchanges that would take someone manually an hour to process, a Python script could just download it in 20 seconds. So that's how it started, completely organically. And I kept on doing that. And after a couple months, few months, I figured that I had there were too many things to solve, all organic problems that we discovered, and we needed one more person. And then we hired our first engineer after me. Now we had the tech team had two people. So the same process continued. After a few months, we had more things to fix. We had more little projects to do. Then we said, need to add more hands. Then the third engineer came in. So as the problems space expanded, the team also very slowly expanded. And how we hired, I mean, most of our hires have been from Hasgeek's job board. So there's that. So just a post, and we spoke to people, and the criteria was really simple: hobbies programmer with some cool little hobby projects. Educational qualifications didn't matter, work experience didn't matter. In fact, I think 90% of the people in the team have had no prior industry work experience. So uh, the team evolved very organically. We got our first designer, I think, in late 2016 or early 2017. So on day one, we didn't say that we need a designer. So when we felt that it was time to have someone look at design, focus on design full time, we got a designer. Then we had, uh, I think, a year and a half later, when we felt that we need two more hands, a pair of extra hands to do design, we had another designer. And everyone who came in, they were all hobbyists. So that's how the team has grown completely organically. Never planned on day one that we need a DevOps team, we need a deployment team, we need a database team, we need an engineering team. Sorry, product management team. We never had that. So today there's 30 of us. We have two designers. Everybody else is a full stack developer. Two people focus on DevOps, uh, and that's a recent the DevOps team was formed, I think, several months ago, last year, earlier this year. Karan, who's a full stack developer, so one day he just stood up and said, "I want to be DevOps," and suddenly we had a DevOps team. But even these little departments are organic focuses. When somebody felt that time to spend, it was time to focus on something called DevOps. Figure out deployments. Make a system around it. We suddenly had a DevOps team. So the whole team has evolved very organically, and the only criteria has been full stack hobbies developers. Yeah.
Uh, and what's the team size? Tech team size?
Yeah, sorry, it's 30 of us. That includes two designers, two people who focus on DevOps. But apart from the two designers, everybody else is a full stack developer. Oh, there's one person, Shantanu, who's not a developer. He joined us last year from another department, and he helps us deal with all the communication that happens with the rest of the company. Zerodha is 1,100 people strong. So Zerodha is a large company, but the tech team is 30. So we need a pair of full-time hands just to deal with the communication with other departments.
Interesting. So I think there are a lot of questions pouring in. I don't think I'll do justice to all of them. So let me try to kind of ask some of these questions. Okay.
Yeah.
So one is like, how do you manage your logs and monitoring at scale?
So Karan, in fact, has written a really good blog post on our entire monitoring setup. So we use Prometheus, we use Grafana, and we have different kinds of agents, exporters embedded into all sorts of things. They extract real-time metrics from Postgres, Redis, our processes, HTTP requests, AWS metrics, and everything is aggregated on a Grafana dashboard. We have lots and lots of dashboards on the Grafana instances. It's all backed by a Victoria Metrics DB. It's a time series database. I think it has billions of records again. Works even a single node can scale really well. Lots of alerts and alarms set on a Prometheus plus Victoria Metrics plus Grafana setup. So that works really well. We get good insights into all corners of the system, and not just system metrics, but app level, semantic app level metrics. We we use Metabase for aggregating more higher level business metrics and numbers also. And sorry, there was something else that you asked. I missed that.
Logs
Oh
also.
yeah, yeah, right. So we have Kibana. We are required by law to store certain kinds of logs for up to 3 years. So we have different indexes with different retention policies for that, and we have Kibana. We use Kibana to aggregate logs from many different sources.
And what's kind of scale like? I'm sure like must be kind of quite a typical
With
lot
several,
that you get.
yeah, the underlying storage is several terabytes in size, and the elk stack is reasonably slow for really large queries, but that's a fair trade-off for passive logging.
Got it. So let me see if I have more questions. Yeah. So other question that a lot of people ask is like, were there any failures that you kind of handled? Okay, and what were the lessons learned?
I mean, there are countless tiny failures that we've handled. And thankfully, with our real time trading platforms, Kite, we haven't really had internal failures. We had significant uh, issues in 2018 and 19. And in fact, today we had an issue where ticks stopped for 60 seconds. That's because a P2P lease line abruptly died, and it's supposed to automatically fail over, and it has in the past. But you know how technology is, it didn't. But then it came back up. So it was 60 seconds worth of drop in market feeds because uh, one of the lines just died, went bonkers. Sorry, went black. So there are lots of these little lessons that happen just like in any complex technology stack. But one of the biggest lessons that we've learned being in this industry is building scale on top of infrastructure, institutional infrastructure that is not built for scale. So the exchanges, the repositories, all these institutions on top of which we built our scale, they were never really built for 2020 levels of scale, millions of trades a day, etc. They were never. So it's been very painful, the journey to building the scale that we have in our stack on top of these limited things. For example, we have to pull an exchange lease line that you pull up until 2 years ago. The max capacity of a lease line, I think, was to 400 messages per second, which is, let's say, 400 orders that you can push to the exchanges per second. And each lease line takes months to commission. There's bureaucracy, there's all of that. So you apply for a line to process 400 more orders per second, and it takes 3 or 4 n number of months for it to commission, for it to be commissioned. So how do you scale on top of that, right? So we 2018-19 we had tons of those institutional issues, but of course it's still, I mean, it's Zerodha as an entity's issue, but unfortunately, most of these things were completely out of a stack. So that was a really painful experience when something goes wrong and you know where it's gone wrong, but there's nothing you can do about it because there are inherent institutional limitations. How do you patch that, or how do you build hacks and scale on top of that? Those lessons have been extremely valuable and painful. So the exchanges recently upped the limit to 1,000 uh, messages per second. But if you think about it, that's really nothing. So one physical lease line that takes months to commission can do 1,000 things per second. Now imagine 2 months from now, suddenly our client base doubles and we are supposed to process 2x the orders. But the exchanges don't even have the capacity to accept so many orders. How do you deal with that? So you always have to over provision. So yeah, these are the biggest pain points that we've had, and the biggest failures have all originated from these things outside of our control. So we just have to live with that, building stuff on somebody else's stack.
So I think my question was more on actually, were there any things that you've done as an architecture wise didn't work out as you expected, and
Oh,
you had to kind of roll back or do something else with that?
I think you could have interrupted me. I went on a rant for like 3 minutes and I wasn't
No,
even
no, no.
answering your
That's quite
question.
valuable. But I was kind of also want to look at the other side of it.
Yeah, so the first version of Kite, when we launched it in 2000, late 2015, early 2016, was written in Python, CherryPy server, HTTP server, and we used AngularJS as a front end. But you can scale Python, but because of its design, because of the heavy runtime, because of GIL, it's not really meant for super low latency, high throughput services. So one single Go service today that we have can handle, let's say, 100,000 HTTP requests per second, and no dependency, nothing. You just run that program, you just run that binary, and it works. But you can't do that in Python. You have to have workers. Each worker consumes resources to handle that whole Python VM. And we tried UVisG, we tried Gunicorn. So, but thankfully we only had 1,000th the scale we have today. So we figured that Python, or pretty much any interpreted language that has a VM, a reasonably heavy VM, was not ideal for building a trading platform. Or if you had to do that, you would have had to expend a lot of resources on hardware to make it scale. So that was an extremely valuable lesson. And switching to Go was has in fact been very pivotal to us. I was experimenting with Go in personal capacity in around 2014, and I don't think Go was very big then. 2000 early 2014. So we started porting small little components that we'd written in Python to Go, and eventually scaled it from that. So that has been an extremely valuable lesson. But our other technology choices like Redis and Postgres, or even MySQL in some places, they've been they've never really failed us. And also the fact that we use Python and Frappe for our non-latency critical heavy data stuff in the backend, that also works well. So yeah, I think that's it. That's the switching from Python to Go for high concurrency, really low resources, and throughput was the single biggest technology switch that we did, and everything else has been quite all right.
So, so what's your uh, plans for your tech architecture? Like, how is it going to evolve soon? Is there some questions about that?
I, uh, like I said, we don't really have grand plans at Zerodha as a business. So we solve small little problems at a time, and you solve one problem and that is sorted. You might see something else worth solving. And I'm talking about user experience business. So the technology and architecture kind of follows that. And another important thing that we do is we're very wary of technical debt. So we've rewritten some of our systems multiple times. In fact, the entire console backend has been rewritten from Python to Go, and we were just doing a final review yesterday. So we found it to be like 10x faster, easier to deploy, and uses a fraction of the resources. So we internally, when we are not building new features, we are always cleaning up systems, cleaning up architecture, rewriting components. Kite Ticker, the program that streams market data, it's been rewritten 6 times, and it has gone from using a custom TCP protocol for communication to the Mangos protocol to Zero MQ to Nano Message, all of these things, to finally using NATs, and from using channels to mutexes. I mean, just to give you an example. So continuously uh, cleaning things up, keeping systems lean, and reducing technical debt is how we evolve the stack. We don't really have a goal, for example, to change everything into uh, something else entirely in the next 12 months. We don't work like that. We always look at little pieces and solve them meaningfully. So it could be reducing latency in a process from 20 ms to 10 ms, or it could just be rewriting a whole different system for the sixth time because it can just get better. And into this process, you bring in the whole process of building new features and evolving the product as the business slash market needs change.
Yeah. So the other side is like you're also kind of very strong proponent of free software. You're one of the people who started FOSS United with Rishabh. So what's your uh, uh, ideas of free software, and then that in actually how does that relate to building an organization?
I mean, it's unfortunate that we have to even have this discussion in 2020, if you think about it. So it's as simple as I wouldn't be sitting here today talking about this stuff if it wasn't for FOSS. I wouldn't have become a programmer. I wouldn't have learned the things I have learned. I wouldn't have done the things I've done. Zerodha wouldn't exist without free software. I don't think the world we know today, as we know it, wouldn't exist without free software. So it's a no-brainer. I mean, even the question, would you use proprietary versus free, etc. I think they are in 2020 they're meaningless. We, like I said, Zerodha wouldn't exist if it wasn't for free software, be it Go, Redis, Postgres, MySQL, or Frappe, ERP Next. Absolutely everything that we use is FOSS. Why the scale we've achieved is thanks to FOSS. The technological efficiency, thanks to FOSS. The regulatory agility, thanks to FOSS. Being able to build all of this with zero external funding, keeping the team lean, keeping the stack lean and efficient, thanks to FOSS. So that's my philosophy. I as a programmer, I started learning programming by looking at copy pasting code from the internet that other people had posted. I had no concept of free software then, but it just seemed natural to me. I copied somebody's code, modified it, played around with it, learned, and I posted it back on the internet. Eventually, I figured out that it's called FOSS and there are licenses, but it just seemed natural. If it wasn't for that in the early days, this was some 20 years ago, I definitely would not have become a developer or even built anything meaningful. So unquestionably, yeah,
So, expanding on that. So, let's say you have to give an advice to an young engineer or someone still in the college, right? I mean, what would be your advice? I mean, what to kind of focus on?
it's. I think the one thing that I can say from my personal experience as a developer is that you have to keep developing. You have to keep writing code. You have to keep building tools. Whether you're doing it for a company where it's your job or you're doing it for hobby, unless you experiment constantly, unless you write code, unless you build little tools or even large tools that are useful for people that solve problems, it's very difficult to mature as a developer. You can read all the books you want, you can read, listen to all the podcasts you want, but if you don't have experience in writing software from scratch, connecting to a database from scratch, understanding how SQL works or NoSQL works from scratch, and by building software on top of it to solve people's problems so that you get a perspective on usability and how human beings interact with software, it's very difficult to mature as a developer. So if you're a developer, you should develop software that solves little problems so that it helps others and also you can grow as a developer. So that would be my one advice. You have to constantly write software and experiment.
Yeah. So thanks. There are a lot of questions that maybe I think we should write a blog post on. For example, how do you scale Redis and how do you use Redis, how do you use Postgres, etc. So I think there are a lot of things people are waiting to hear more about, more detailed stuff. I think those things you can plan for blog posts, many of those stuff. There are
Yeah.
some also questions about like hiring. Right? I mean, how do you hire? I mean, what's your hiring process? Just to kind of answer. There are many questions. I just thought uh, good to kind of bring that up.
Cool. On Redis is pure magic. I think it's, I absolutely am a huge Redis fan. It is absolutely just pure magic. You you install Redis, you run it, you maybe disable writing to disk flushing and do with replicas to remove that latency, and Redis will practically scale forever as long as it has enough CPU and RAM. And it's just absolutely, it's beautiful to work with. It's a beautiful piece of technology and it is so usable. Unlike many other different, even Postgres is not, even Postgres, it's a little hard to install, set up, create a user, run stuff. Redis is just, Redis nails all of these aspects. So scaling Redis is easy. You install, you run, that's it. It just scales. There's no knobs to tune. Hiring, as I said again, we don't really look at, we've never looked at industry experience, and we don't really have a hiring quota. So this year, I don't know, I think maybe we've added one person, or I don't even know, maybe that was last year. So we only hire when there is, we feel as a team that we need more hands to solve a problem, or we've reached a limit as a team. That's when we hire someone. And that someone, it doesn't, their educational qualifications don't matter, their work experience doesn't matter, but their aptitude as a developer matters. And as I said, if you do hobby projects, if you're passionate about doing hobby projects, I think that's a good indicator of how you'd be as a developer, because you're doing these things because you like it, not really for a particular job or not because somebody asked you to do. So the hiring process is simple. You look at somebody's portfolio, which is what they've done, their hobby projects or whatever they work, and you speak to them, and that's about it. There's actually one really simple task that we send out to when we're hiring developers for beginner to intermediate positions. It's literally write a Python app which scrapes a particular page from NSE's website and runs a cherry pie server with a search box. It's really simple. It is not intended to uh, judge somebody's technical proficiency because that can be learned, but it's meant to judge people's attitude. The task is so simple. You can tell a lot by how someone approaches it. Some people just don't care at all. They just, there's no comments, for example. So that all of that shows attitude. So when we hire, the single biggest factor we look at uh, uh, is the person a hobbyist hacker? Do they like developing? Yeah,
There's one question I think I can answer that. The
yeah.
question from Sagar Manjara is, do you still code, Kailash? I think he does, and it was 2 minutes we were waiting, and he was banging on the keyboard, so you know what he's doing. So
Oh yeah, I mean, if you don't code, then you're no longer a developer. And honestly, the only thing I like being really is a developer. So yeah, of course, I write code every single day. All of us in the team, all of us are full stack developers. We write code every single day, 6 hours a day, 8 hours a day, 14 hours a day. Yeah.
I think we're pretty much. I think we're just crossed our time, 7:30. I think I have one last question, and then see if there are any more questions. I think I went through most of the questions that are there in the chat. So when you look at the most of the startups right now, and they're starting to scale, a lot of times, like the most of the funded startups, I think they have team sizes which are goes into hundreds of people, and so uh, I mean, so do you see any problem in the way that industry kind of approaching scaling or building teams, or is it something that Zero has been have a different kind of space? So how do you kind of see that?
I think it's a serious problem. I think massive tech teams are a huge problem, and the business slows down, the communication slows down, the efficiency goes away. You have lots of departments that now need to coordinate. You probably have five people trying to solve the same problem where one good developer could just solve it. And most importantly, I think developers become jaded. So imagine you're at a mutual fund platform and you have 300 developers. What are 300 developers doing, right? Everyone will probably get a tiny little thing to work on, and they can feel no ownership of it. They get a requirement, they write a few lines of code, they fix a bug or whatever, and they push it. There's no sense of ownership. There's no sense of growth as a developer. But in a small team, every single person in the team, including me, all of us, we own many different stacks that we operate on. All of us are principal developers on one of the hundreds of projects that we maintain internally. So it's just it's good for developer morale. And I think again, with our experience, if you use us as a case study, I think smaller teams are far more efficient and scalable. So even by taking things cautiously and slowly, we are still far ahead of, let's say, our competition. We push out way more things than anybody else with really tiny teams. So it shows that people are generally happier, and the work is more meaningful because you get to own things. The communication between people, we are like a social club. Our tech team, we are like a social club. We have fun. We work together. There are no uh, departments within the team. I mean, it's very casual, the environment. So this tendency of growing really large teams, I really don't understand. And I think even the fact that certain companies, startups, when they start out on day one, they say we need a DevOps team with 4 people. We need a whatever team with front end. We need 6 front end developers. We need 8 backend developers. You can't quantify developers into units. You can't say that this project requires 2 human developers to build. You might require 10, you might require 20, you might just require one. But on day one, setting these goals and hiring big teams, I've never understood how that works. And I think it's pretty meaningless to quantify developers into units, human units, where you say that we're going to hire 4 front end developers, they'll build a website. That's not how it works.
Interesting. So I think we're open for more questions. I think I'm kind of it's done with the stuff that I kind of want to ask. Josna says we can continue for 10, 15 minutes. So people can continue pouring your questions. I think I'll pass on them to Kailash. So if no one has anything, I think I have some of them I've written down. Let me kind of go over my list.
I just got a pop up. I think Karan is sending some nonsense on our tech group. I think he's watching it.
Interesting. Yeah. So one of the question is from Shubham is when can engineer be confident that they'll be able to make and handle good technical decisions?
Always and never. I know it's a weird answer, but it is. It has to come with experience, and that could be 2 years, that could be 20 years, and that entirely depends on the problem. There is no such thing as a technical problem that needs uh, a solid decision. There are an infinite number of technical problems in varying complexity. A technical problem at a stockbroker might be completely different from a technical problem at another company. So unless you are in it, unless you have your hands dirty, and unless you have been doing it for a while, building experience, writing systems, building and breaking systems, not in the fail fast sense, it's impossible. So there's no metric to that. I personally, lots of decisions are really easy for me from personal experience. Lots of decisions scare me. So I think that will always be the case for any developer. It all depends on the environment.
So one of the question from Abhishek is like you're always hiring when you're hiring people, you're not looking at their technical skill, but only at the attitude. So now, how does the mentoring work at Zerodha? When do you take them? Is there a period where they actually work with someone and then kind of someone mentors them? How does that work?
It's not true that we don't look at technical skills. Of course we look. I mean, we would not hire non-developers, right? That's why we hire hobbyists, and hobbyists have work to show. They have programmed little things. So of course there's a clear indication of their technical prowess when we hire them. But for beginners, mentoring is simple. Because we are a flat team, and until COVID happened, all of us would just sit together. I mean, on one floor. There were, you know, 20, 30 of us, 30 of us now. It's a flat team, so everybody would just sit with everybody else uh, and work with each other. And beginners always, when they come in, they always get a real task to do, something really non-critical. It could just be a simple automation script, something, and once they did that, whoever gave it to them, it could be the console team, could be the kite team, they would sit with them and tell them that this is right, this is wrong, this is how it should be done. So you do one tiny real project, then you do a slightly bigger real project, and a slightly bigger real project. Keyword being, these are all real little projects, and gradually you graduate them into a more serious project, and after that they just become embedded in one of those projects. So mentoring is very hands on. You give people real projects, real tasks, really small non-critical ones. You sit with them. Personally, I've sat with, I think, everyone and written code with them. I've debugged people's programs, and all of us in our team, we go sit with each other and debug each other's programs. So mentoring is uh, hands-on, one-on-one, and everybody in the team helps and mentors everybody else, especially beginners.
So, were there any hires that didn't work out for you?
Yeah, there have been. So I think over the last 7 years, 7.5 years, I think we've let maybe five people go, five or six, can't recollect, but yeah, small number. Yeah,
So there are a bunch of more questions. How does authentication and authorization is handled across across your platform?
there are we use multiple things. We for There's the Kong API gateway that we use as a central gateway for internal non-critical, non-low latency internal API services where things communicate with each other. And for certain things, we have IAM roles. That's the Amazon identity concept, where certain big systems have to interact with certain other big systems. And for all our external applications, they're all first class citizens built on top of our Kite Connect API. So Coin, Console, all of these systems for end user authentication, we use the Kite Connect auth system. And that makes it really simple because it's the same auth system that all the external platforms and systems also use. So all these apps are first class citizens. So all external auth is Kite Connect between apps, and internal auth is a mix of many things, including, like I said, the Kong API gateway. We don't use a hosted API gateway.
So Ganesh has a question. How your internal small and large services communicate with each other?
Sorry, I didn't catch that.
How does the internal services talk to each other?
Internal services talk to each other via HTTP APIs, and if it's back and forth communication, for a lot of our systems, it's just one-way communication. So we have like a Kafka backbone. We use it like a company-wide bus into which systems push data, and lots of little consumers from different departments, completely different segments consume. For instance, let's say there's a fund update. A lot of different systems that don't have access to each other, they don't even know each other. Let's say a back office system and the trading platform system that have no knowledge of each other might need the same data. So all of them just connect to this central Kafka bus and consume data. So this is only for one-way communication. For pretty much everything else, we use just simple HTTP APIs.
Yeah. So one of the questions is, since major parts of Zerodha are written in Frappe, and you still say that you're agile while depending on a vendor. So
No, we don't have vendor, right? Frappe, the framework we use, just like we use Django. There's no vendor. We just
yeah.
use it internally. We built all our modules ourselves. We host it ourselves.
So other question is actually about the industry, not really about scaling. How do you overcome the fear of financial penalties if mistake happens in the fintech industry?
I think fear of financial penalties is the least of our fears, to be honest. Penalties you can pay and you can get off, but imagine having a catastrophic event like a bunch of lease line failures or a data center failure, and there are millions of people who are unable to make critical, crucial financial transactions. So that fear and the inherent risk in stockbroking, which is infinite risk for a stockbroker because we do leveraged trades, complex derivative instruments. These two fears trump all our fears. To be honest, if there were no other issues but paying penalties, that would have been much simpler for the whole industry. But every broker has 100 other really crazy fears that they have to sleep with. It's a part of life, really.
So they're interesting. So other question about again teams is, how does product management and tech teams uh, work together?
We don't have product managers. So yeah, we don't have any product managers. As I said, everybody's a full stack developer, and there are two designers, and we form small units and design. The two designers that we have, they work with different applications and teams, and I think at this point, some of us, we've emerged to be product developer plus product managers. So Vivek and I, for instance, we product manage Kite. We also develop Kite, and the console team, the team themselves are developers and product managers, and all of us work with designers. So we don't have dedicated product managers. Developers themselves work like product managers. And when it comes to certain financial things that we may not really have insight into, we get help from, let's say, the people who sit with Nitin. Nitin has a team called the Z team, and Nitin is the CEO of Zerodha. So the Z team, they have expertise and knowledge in a lot of things pertaining to the markets, behavior, traders, psychology, etc. So ideas come from them. We sit with them. So yeah, it's it's very pragmatic product management. We don't have dedicated product managers.
I think there's still some more questions. I think I will have to kind of leave them because we're already past 15 minutes. I think, yeah. So thanks, Kailash. I think it's really quite engaging discussion, and it's something really fascinating to kind of know something that's not usual way of building an organization or building tech stacks. Usually, we hear about people talking about scale in a sense that they throw more resources at it rather than kind of approaching first principles. It's quite interesting to kind of see something that I myself kind of try to kind of believe in and kind of see a success story and come on the show and talk about it. Thanks a lot, and
Thank
I
you. Thank
hope
you.
everyone really enjoyed the series. Uh, Thanks everyone, and we'll be back with one more in the next month. Thank you
Thanks.
all.
Thanks, Anand. Thank you. Thank you. Bye.
Bye everyone.